Yeah, I'll have to faff with that. Right. So this meeting is now being live streamed. Cool. So can you all see my slides? That's the next question. Do we get a thumbs up? Yeah, I see nods. That's at least enough. All right, folks, we're going to get going. Right. So this meeting, and I can hear myself, which is nice. So mute it. There we go. Mute myself. There we go. There, just in time. So now I need to go back to too many things on the screen at the same time now. Right, good. So thank you very much for coming to .NET Knots. I've pointed the camera at the people that aren't me because, you know, rather you look at the room than me, just in case you're wondering why you're seeing a room full of people instead of my smiley face. We are back in person and on Zoom, so hybrid. And in both cases, we've got a code of conduct, which really boils down to be nice to people. But if you think that anybody might be breaking our code of conduct, then in fact, your point of contact tonight is Connell in the chat. If you are on Zoom, if you are in person and you feel that you've been affected in any way by someone's behavior, then please come to me and I will do my best to remediate any issues that you might have. There's some more details there. If you go to that bit.ly, you can see some more details about our code of conduct. We'd like to thank our sponsors, BGSS, because those of us that are in person are sitting in their offices. So thank you to them for letting us do that. And I know that there was a bit of moving around to make that happen as well. So I appreciate that amount of effort. Cordius are back as our sponsor for the beer and the pizza, which I've just ordered in a rush, which I'm hoping that nothing went wrong with the order. That should be coming, according to their app, ASAP. There is no other option. So it might well appear within the next 20 minutes, in which case, yeah, you can speak at M&M speed, I've heard, so it will work like that. I put my company on there because tax, and also, you know, but JetBrains are also sponsoring us a JetBrains license, which I'll talk about shortly, and Calix are sponsoring us our Zoom license that you nice folks sitting in the remote world are using, and also they're sponsoring us a prize tonight too. Talking about prizes, JetBrains, if you don't know what they do, they make developer tools for developers. I think most folks have heard of JetBrains these days, and they're sponsoring us a code for any single one of their products. So that's WebStorm, PHP Storm, Rider, IntelliJ, all of those things. So you need to tweet on the hashtag .NETKnots, which will be a theme between this and the next slide. And then hopefully tonight, because we really need to do that, we will try and draw out a winner and then we'll DM you. So make sure you're following us on Twitter. Likewise, Calix, they're sponsoring us a book, which has been chosen, in fact, by Steve, C# 10 with .NET 6, which is, I would like to win that myself, actually. Looks like quite a good book. So again, if you tweet on the hashtag .NETKnots, then we'll try and draw out a random person to win that. And I'm afraid, sorry, those folks that are remote and not in the UK, unfortunately, you cannot win that. Because of postage. But other than that, you will be able to have a chance of winning the JetBrains license. There's a bunch of us, in fact, your speaker tonight is also an MVP. And several of the people here, in fact, Stefan, congratulations. I've not seen you since. Congratulations on your new MVP. You won't see who I'm speaking to, they're remote. But if you're interested in learning a little bit more about what a Microsoft Most Valuable Professional is, then please do ask, and any one of us can fill you in on that program. Tonight, we have Stephen Pears, who stood next to me. You can't see him if you're remote. He's hiding. But he will be talking about .NET and Roslyn, so quite looking forward to that. And from next month, which is alarmingly soon now, the Festive Tech Calendar is on. So do check that out. There will be talks all day, every day, pretty much. So that's an awesome program of talks, tech talks, and soft skills talks. So with that, I'll stop my slides and we'll do the Zoom switching, and you can share your screen and we'll go from there. So thank you very much. So let's stop that, close that. Yeah, well, you can soon move to my location if you are. You might well be a little bit, possibly. Yeah. I'm going to unspotlight myself as well. Oh, in fact, that's probably already done it, but move spotlight. Yeah, you might want to move up. Yeah, because that's blinding. Oh, and you'll need this because you need to present up on there, probably. Oh, no, we can do it this way. No, we'll do it this way. Okay. It'll work because you're coming out of here anyway, so ignore me.
Okay.
Last month we just duplicated and put you straight up onto there, but this will work just as well, although
you're using my mic.
I'm just worried about lag. Probably be all right. Yeah, your mic
I'm
on
not
there.
doing anything particularly fast. I think we should be okay.
Yeah.
I mean, my demos will, well, they'll either work or they won't, but I don't think lag's going to make a difference. So it should be okay. Okay. Can people hear me on the Zoom call? Because I've unmuted, so let's just make sure.
Oh yeah, we've got a big thumbs up.
Yep. Cool. Thanks, Connor. Cool. Okay then. Yeah. Great. Oh, this is really weird. I'm a really tall person in a really small box. This is very unnerving. So yeah, if I keep looking around like I'm scared, it's because I am a little bit. Plus, certainly for the people online, I'm going to be doing this a lot, and I've just realized you're going to just see these two pairs of there's two hands doing this a lot. I really apologize, but normally I'd be pacing backwards and forwards. And because I'm doing this off my laptop, it's going to be a little bit peculiar. So yeah, a little bit odd. Get this out of the way first of all, though. This is a talk about a thing that I am doing. I'm slightly scared by the flashy tech. No, we're good. Right. Okay. No, it's fine. Yeah, I'm rambling for like the next 45 minutes about stuff. Right, and a minute.
Right.
So in-person stuff, just yeah.
So is that all of your slides?
That is literally it. Yeah. Yeah. Until the demos kick in, there won't be a huge amount of staring at the presentation. That's fine. But yeah, I'm literally just distracted by shiny things. I have a look at stuff, I move around, I look at it again, I go, that looks fun, and then I carry on. So because of that, and because of the fact it is just me rambling for 45 minutes, if you've got questions and stuff, just chip in. That's fine. I've already told those online if there are questions that I'm missing in the chat because I'm too busy trying to make my demos work. By all means, interrupt and Pete sort me out and get that wired up. But this is not, I am an expert in a thing and I want to talk about it. It's, I like shiny stuff, and this is kind of a cool shiny thing. And I want to talk about it because I love what I'm doing at the moment with .NET. And I've been very lucky with the open source projects that I get to work with. And basically, Roslyn's made that better for me. So I just want to talk about that journey a little bit. Quick bit about me, .NET developer. I say for too long, I was sent the original 1.0 beta in 2000 on CD, I want to say. So it gives you an idea of how long ago that was. But I've been lucky enough to work with .NET since it came out. I'm now a Microsoft MVP for developer technologies. So Microsoft now go, that guy is somebody who is just like distracted by shiny things. But the big thing for me is that I am lucky enough to work on some .NET libraries in the open source world. The two that I'm kind of proud of, Tim Hewer created Alexa.NET, and I'm now one of the co-authors on that. So that is for anyone who wants to deal with Alexa skills in .NET. That's kind of the library at the moment because it's not a supported language. And then Slack, off the back of the work I did with Alexa, I started looking at Slack SDKs, and .NET is not a supported language in that either. So I created Slack.NET Standard. There were other libraries kicking around, but I didn't like them. And they had some functionality missing. And I was like, I can have a go at that. And that's just become a whole thing now. It was supposed to be, I want to create a quick Slack app, and turned into, actually, I support everything that we do with Slack now. So that's been a lot of fun. But essentially, this is where I started dealing with open source and Roslyn. So I did a talk a while back, and actually the guy running the talk was like, actually, can you just make sure that you talk a bit more about open source? So I just wanted to be clear about what I mean. Certainly for the purposes of this talk, some people are very precious about what open source means. That's a whole different thing and a whole different discussion. Open source here is literally just code that you maintain that other people are going to submit to, and potentially they're not in the room. So you can't have that conversation with them. For my purposes and for what I do, that's all open source is. I create stuff that's kind of useful and I dump it onto NuGet and I go, use that if it's useful. And then the issue that I've got is that there is a lot of people trying to do that and they have issues and that takes time. I'd forgotten about that slide actually. I put that slide in because it's not just open source. Because I didn't want to specifically go, this is just open source. It's not. What I mean is anything where there is an open source mentality. If you are dealing with private NuGet packages in .NET, but you have teams of people who are the other side of the world who can contribute code. My previous role, I worked with a dozen or so teams. There were a bunch of shared libraries. Anyone could commit to them, but they all managed some core functionality for the business. There was complex business logic in there. That is something that can help with the work that I'm dealing with today. So although my context is open source and my experience has been with open source projects, I'm talking about anything where team size makes it difficult to maintain standards or have conversations with everyone who contributes, be that size, geography, the fact that you've got churn, whatever it is, you end up in a position where people are contributing and they don't necessarily know, I'll put in inverted commas, the rules for how you want that code to be managed. And essentially the bottom line is it's all about time. Certainly with open source, I've got contributors who are trying to help me by adding code and they are taking their time out to make that better. And if they raise a PR request, or if you've got a team that raises a PR request and there are rules that best will in the world, even if you put it in a README or even if you put it in a contributing file, developers are going to download the code and tap it out and go, I made this change. If there's a rule there that they didn't know about or they couldn't maintain, or there is anything there that means that process is more painful than it needs to be, those contributors are taking their time. You've got users who are trying to use your NuGet package and actually trying to use your end product, and anything that makes that difficult is taking up their time. They will then raise issues, which you have to then deal with. And essentially it boils down to your time is valuable as well. I've got those two open source projects. I'm quite lucky in the fact that they're little niche things, quite nice, but the bigger the project gets, suddenly you get more issues, you get more questions. And if these are things that could be handled by a system helping you, or by technology going, actually, there's this thing that you didn't know about, anything that means they don't have to deal with, add more of their time, means that yours is spent doing what you love doing, which is normally writing code or working on something new and shiny, or in my case, going, oh, there's that over there, and going in a completely different direction. So anything that can make time, make you use less time to maintain these packages is a good deal. That's what I'm trying to get at. So it's not just the fact that I'm in the open source world, it's just that's where I've found the value comes from. So open source was one part of the title, Roslyn is the other. Actually, for a lot of .NET developers, not necessarily a lot of people know what Roslyn is. So Roslyn is the code name for the project that is, I'm probably going to get it wrong, the title, something that just rolls off the tongue. It's the .NET Compiler Platform APIs, I think is the official title. Essentially, a lot of smart people decided that the compiler for .NET was going to be run using .NET. It was going to run itself. So inside .NET, there are a bunch of APIs that you can use which allow you to compile code, which is great. It's absolutely what you want. And the reason that you want this is because it means that Roslyn is something that allows you to hook into a bunch of functionality that the .NET platform offers and goes, yeah, we can compile code, but you can also do ... And that ... is stuff they've been adding to for the last few versions of .NET. For the sake of this talk, because I'm not an expert on the Roslyn, because quite frankly, I'll lose most of the people in the room and online if I start talking about the internal workings of Roslyn, because I don't know them very well. There are 4 stages which I really want people who are dealing with .NET to worry about. You start on the far left, you have got your code. That is the thing that you write. It's beautiful, it's wonderful, it works, it's tested, great. And you are trying to get to the bit at the end, which is your compiled code. It's your gold standard. It's what you want to run. It's wonderful. Roslyn, during the process of going from code to compile, offers you 2 new sections. And these sections are things that you can start interrogating and having a look at. The first is that you have your code turned into syntax. Syntax is basically turning your nice, lovely code into an object model. But it is based purely on the language. It understands that you have written this code, and therefore, if I have, for example, test with a parameter of X passed in, I have a method, it is called test, there is an argument, it is called X. And from there, you can go up and down that tree. At the very top, there is something called a compilation unit, which is, this is a thing I want you to compile. And you can go all the way down to, this is X, which is the variable. And you can move up and down as you would any other tree. You can look at the parent. So what is the parent of X? It's the arguments. What is the parent of that? It's the method. And you can manipulate that syntax. After the syntax, you have what's called the semantic stage. So essentially, it's got the syntax. It knows that all this stuff exists. But for example, you've got X. X doesn't mean anything at that point. It is just an identifier. It is a name. What Roslyn does is take your syntax, then takes all the other information that it's going to use for a compilation, like all the references that you've put in, the namespaces, the modules that exist, your NuGet packages, interrogates all that and starts figuring an extra layer of metadata out about your code and turns that into a semantic object model. So it's another object model, but now it can just be a little bit more clever. So now it can go, well, yeah, you've got a method, and yes, you've got an argument in there, and that's called X. But now I know that X is a field, not just a name, it's a field. This method is in this class. This class is in this namespace. So now you can start putting extra logic in that potentially isn't necessarily to do with your syntax, but it's once it's all combined together, excuse me, you're going to end up with a semantic model. And what Roslyn allows .NET developers to do is hook into the syntax and the semantic model as they get built and start tweaking the next stages in that pipeline so that actually what you compile can be a little different to what you put through in code. Sorry for the people online, this is going to look like a massive jug. It is. It just looks extra big online. So that's as much as I'm going to go into the Roslyn stages at the moment. You have code, you have syntax, you have semantic, you have compile, and then we hook in. So that's all great. We have these 4 stages that are Roslyn, but what does that mean? What can you do? Well, essentially, there are particular hooks that you can get interested in and start interrogating these different stages of Roslyn. So the first thing I'm going to talk about is analyzers. Roslyn analyzers are exactly what they say. Naming is actually quite good for once in .NET. It allows you to analyze the code. It allows you to analyze the code in either the syntax or the semantic. And what Roslyn analyzers allow you to do is say, I care about this bit of the language. So you can say, I care about any time you are compiling code and you come across a class. Or I care about any time you come across a method or a property or a string literal. String literal is quite a good one. A lot of code, like you don't want string literals in your code. It must be a constant or it must be a resource if you're multi-language. So a simple thing is, I want to know anytime this happened. And at that point, once you've got the Roslyn analyzer doing that, you can then start creating what are called diagnostics. So we see diagnostics all the time. Diagnostics are essentially these things you see when your code doesn't work inside Visual Studio or in a .NET in the CLI. And it's been a while since I've done a talk. My math's getting dry already. So essentially, you have Roslyn Analyzer saying, I will tell you every time this exists, and then every time this exists, you can create a diagnostic. What does that help when it deals with open source? Well, from my point of view, one of the things that I do with diagnostics is I do have coding standards. One of the projects that I created, the Slack one, forgotten who it was, someone that I respected on Twitter, did a video where he opened up my library and started using it. And the first issue that he came up with is one of my objects used an array. Shouldn't have been a problem, but he was trying to build something at the time. Like, who the hell uses arrays anymore? Everything's a list. I shouldn't have to initialize arrays. I shouldn't have to worry about it. And I hadn't thought about it. It was the way the library was built naturally. I'd started with a read-only part of the system, and then suddenly I'd used the right stuff, and I just reused the class. And there were arrays scattered all over the place, but it was very inconsistent. So I spent time looking at the code and going, well, really, what I want to do is, if this could be used for something that is writable, I want it to be a list. And anytime it's read-only, and there was only a particular namespace where the read-only objects existed, I want it to be an array. And that is an absolute rule. And quite frankly, I wasn't sure I'd stick to it. I write code in a bit of a haze. I'm knocking up object models. I'm the only contributor at the moment to my code. I'm really going to worry about that. So what I started looking at was a diagnostic that said, anytime there is a property anywhere in the system, check to see what the type is, check to see if the type is an array. And if it is, raise a warning and say it should be a list. And then I turned warning as errors, so I couldn't compile my own code if that happened. And it worked, and it was great. And I used the syntax model for that. That was brilliant. Right up until the point where I had an events API, which are just events that stream to me. Never going to need a list. They're only ever read-only. Great, that needs to be an array. And suddenly I'm like, well, I have no idea what namespace this is in. I'm going to have to go up and calculate the namespace and figure it out and blah, blah, blah. So I created another one, which was in the semantic model that was able to go, absolutely, it should absolutely be a list, unless the semantic model tells me it's in this namespace, in which case they're all fine. That's not a problem. And then I had another exception. But this was it. I had another exception where it was like, actually, this one class is always going to be read-only, but I don't want it to be in the events API. And okay, so I was able to start creating a marker attribute. So an attribute that doesn't do anything, but it was something that you could put on the class to go, I know that this is going to break the rule, but I'm letting it happen, and I'm telling you it's okay because I'm specifically putting that attribute in. So now I've got an analyzer that can come along. Anyone commits any code ever. It goes, if it's a class and it's a property in the class that has got an array type, and it's not in the events namespace, and it hasn't got this attribute in, stick an error on there going, that should absolutely be that problem. Suddenly, I've got a piece of code that runs automatically anytime anyone contributes anything that says that's not quite right. It's not a problem with .NET. It's not a problem with what you've written. You've done everything right. But this is a rule that we implement because it's the logic that I want to put in this package. And suddenly diagnostics become really useful because going back to that list, I've got contributors who are submitting code or are trying to write code for me. And actually Visual Studio is actively telling them, yeah, this is great, but it's going to be a problem if you try and submit this. And we're able to put that in. You've got categories coming up. So these are the ones you'll be used to as compiler and build. But when you create your own diagnostic, that category can be, Slack rules or whatever it happens to be. As long as the code is unique, everything will work, and you can give a description. The description is actually a formatted string. I'll show this in a minute in an example. But the description itself isn't just you got it wrong. It's you can pass in parameters to say this property on this class is currently an array. This library requires this to be a list. So you can make it nice and explanatory, set it all up, but suddenly that contributor knows there's going to be a problem before he's committed the code, rather than putting all the effort in, doing all the release notes, pushing it to you, and you going, no. Now, there's a random rule you didn't know about that might have been in the README, but you didn't read that far down, and you might have forgotten because you've been working on it over 5 days. So suddenly analyzers become hugely useful. Excuse me. So we talk about the code, the title, the message. The only other piece on a diagnostic, and it just because it will get used later, is the location. Every time there is something in your code, you raise a diagnostic, you can say, this is the problem, and it's here where this node is. And the reason for that is when you double click on the diagnostic, it takes you straight to the code. So suddenly you've got something that's really self-explanatory, points them directly at the code they built, because potentially they've got lots of these kicking around, or they've done a lot of changes and they don't know which one you're talking about. It just hooks directly into Visual Studio. But because it's a diagnostic, it means anytime it runs anywhere. If they're running on Linux, it's not the same as, for example, a VS extension, that kind of thing. And it's, I would say real time, but it's every time this runs. So every time .NET's compiling, which for an IDE is a lot more frequently than every time they hit build. Because behind the scenes, you're trying to get IntelliSense help out. You've got Visual Studio trying to tell you that there are problems in real time. So it's compiling your code in the background. And your analyzer is a natural part of that process. So literally, as they're writing, it will start popping up. So I'm going to show, fingers crossed, it's been a long time since I've done a live demo, and I swore I'd never do a talk with live demos in it again. So we'll see how this goes. I will try and do an analyzer and a diagnostic.
Could be Alexa.
Yes. Yes. For those in the room. The only time I've had a full talk failure where every demo died was when I was trying to show Alexa in the room on live demos. There was no internet connection and no phone signal. It wasn't a pleasant day. So move Zoom out the way. And I will have to zoom in a minute. So let's find some projects, because I'll go into those in a minute, all my tests, which I'll show later. Analyzer. Cool. This is where Visual Studio just goes, now you're running more than one instance, your computer's going to say no. Haha, there's some code. There's too much code. This is the final code. Someone was testing their demo and forgot to delete all the little bits of code that you put in. So let's get rid of that. Because I want a blank demo. There we go. Cool. And because of that, I would imagine. Can we get a thumbs up from people online if that's readable, please? Fabulous. Cool. So, going to shut down my demo. Zoom's in the way of all my menus. There we go. Cool. And the first thing I'm going to say is one problem. We'll talk about testing towards the end of the talk. One problem with Visual Studio when you are doing Roslyn work is it tries to be really efficient and it caches everything. So when you are working on an analyzer, one of the biggest problems you're going to have is you're going to write your code and you're going to go, that doesn't work quite right. And then you're going to change the code so it works properly and you're going to hit build and it'll go, that still doesn't work quite right. And you're going to get really frustrated. And you're going to do that for about the first 20 minutes until you go, I'm just going to shut it all down and try again later. And then it suddenly starts working. And it's because behind the scenes, Visual Studio caches it all. So testing becomes a real problem. We'll talk about that towards the end because testing isn't that bad. But when you're trying to do a live demo in Visual Studio, it gets a little bit more awkward. So if I seem like I'm randomly shutting things down, it's not an issue with analyzers. It's the fact that I want the little line at the bottom of my screen to appear. And that means that I have to ask Visual Studio to play nice for a minute. So hopefully now, when I run my demo, it's not going to have cached all that code. There we go. Hopefully that's going to build and it will say nothing's wrong because I haven't written anything yet. Yeah, I might start filtering if it comes up with a bunch of stuff. One of the big .NET problems I've had recently is the fact that I've got to get used to telling .NET when things are nullable and when they aren't. And I'm still not quite used to that often enough. Cool, that seems like it's not going to be too bad. So I've got a very, or Visual Studio's just crashed, one or the other. Lovely. Right. Low system resources may affect your audio quality. Thank you, Zoom. You're aware that you are the low system resource. All right. Honestly, I have run this demo enough times that I know Visual Studio is not the problem on this machine. Yeah. Cool. So that's still dealing. Oh, and it's probably ReSharper deciding that it wants to give me lots of help as well. So that's probably not going to happen. Anyway, so I've got a really, yay, there we go. All my nullable errors. That's fine. But they're all compile errors, so I don't care so much about that. Because that isn't going to stop. Yeah, that's fine. Cool. So I've got a very, 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 very simplistic piece of code because I really want the demo to work. But I don't like the fact that we've got the word world in there. This is going to be a convoluted example. I'm going to show a real one in a minute about how it can work. But I just want to show you the pieces that go together. So this is hello world. And yeah, it's absolutely fine. I just don't like the fact it says world. It's a bit too big. And this is just Nottingham or .NET not specifically. So I'm going to write some code, has a look, and figures out every time there's a string that I don't like. And then I'm going to make it so it comes up and tells me it's a problem. And reminds me that I need to be a little bit more specific because world is a little bit much. So it is a bit of a convoluted example. Cool. So now demo 1. First thing I'm going to do is I'm going to inherit from diagnostic analyzer. Ooh. And then I'm going to say that I can't stop. Really zoom is every single one in the way. Yeah, forgot the rest. There we go. It might not come up when I type analyzer. There we go. Diagnostic analyzer. And I want this to be C# analyzer. Diagnostics don't have to be a particular language. Say what the primary one is, but if you're not using a C# or Visual Basic specific piece of language in your analyzer, then you can absolutely have both. It can run for both. And in fact, I don't know if it's Visual Studio or ReSharper, but one of them will start complaining soon and go, you're not doing anything that's C# specific. Why not be more inclusive with your language? So when you start off, you have doing the demos works fine until Zoom gets in the way. Cool. So you've got a method and a particular property. So essentially, I mentioned that you have to have diagnostics. Your class has to say which diagnostics it supports. So I'm going to create a quick one over here. So you create a diagnostic descriptor. Yeah, it's fast. Give it an ID. You can use resources. So you've got two versions here. You've got the localizable strings, and then you've got just the regular strings. Localizable strings are just you use a resource file, and that's obviously if you're creating a package that's multilingual, you want those to be really useful. This is just for my own demo, so I'm going to put the title of fine message format. So I mentioned before that your messages can be descriptive and passing parameters. That's what the 0 is. So just a string.format kind of thing. Category is going to be .NET Nots. So I'm going to create my own category of analyzer code. This is obviously hugely important. So I'm going to make it an error. It's just not loud. And then is enabled by default. It is true. There we go. So that is the descriptor that I'm trying to raise. That's what I'm trying to make it do. In my context, I can then. So there's a bunch of stuff you can kind of do by default. This is just so I can hopefully get rid of some of the specifics. So you can enable concurrent execution, i.e. this code isn't doing anything that requires state. It can run multiple times. Potentially, if you've got your compilation running in the background and you're hitting build, and then you'll end up with more than one running occasionally. I've got no issue with that. You can say how my analyzer is specifically about a string. You can tell it that actually for generated code, I want it to be ignored. So potentially if you've got an analyzer that says, well, I want to do this thing, but you know you're generating code somewhere, or that something generates code like Entity Framework, that kind of thing, where behind the scenes it's like, yeah, you know what, all that generated code is going to break my rule and I don't care. Then you can specifically say, you know what, just don't worry about it. If it's generated code, I'll ignore it. You can say that actually you want to make it a problem. So if there are particular errors, which means your code should fail, you go, well, I don't care if it's generated or not. That's absolutely not right. And you've got that option then of being able to say what that does. And then you register I'm going to register a syntax node action. So essentially, this is do a thing every time a particular node comes up. So I'm going to create a method, and I'm going to nick it from here. I'm just taking a little longer. Yep. Right. So I'm going to create a method, and then I'm going to say syntax. And then basically you have to say what kind of syntax you want it to flag on. So for me, that's not right. I don't believe that is a stringless expression, actually. And the reason that I don't think that's right is because I'm going to say what happens here. Now, the string literal is what I want to mess around with. But actually, when I ask for what node is at that point, it's not a string literal first, it's an argument first. So it's going to say console.writeLine, which has an argument, and the argument happens to be of type string literal. So I'm going to hopefully say anytime there's an argument, tell me about it. That's fine. So this is the bit that actually registers it. So every time there's an argument, it's going to give me that there's a, I'm going to register that action inside my method. Oh, this is old code, got it. That's going to go obj.node as argument syntax. So all these different syntaxes are the different types. Now, actually, I was going to do this later, but I'll do it now because this demo is just happening. I've moved Zoom in the way of everything every time. I'm doing this like argument syntax is obviously what it would be, and so is literal string expression, and it's fine. It's absolutely not a problem. It's absolutely a problem when you're first starting off with Roslyn. Finding out how things fit together can be a real problem. I use a site called Roslyn Quota, which is a great little bit. It lets me do var text equals text. I stick that in and I hit generate. And what I get down here is all the Roslyn syntax that I would possibly want to tell me how things are broken down. Don't worry about most of that because this is, I'll go into how verbose and painful Roslyn can be sometimes if you're getting complicated. But all I care about is this bit here, which is the arguments at the end. So how do I get to X? It's like, well, actually, there's an argument list. Inside there, there's going to be an argument. The argument's going to have an identifier name. That's the bit I wanted. So I can go, right, well, I know I'm going to be looking for the argument. That argument's going to have a thing in it. So I'm going to go back. Expression. I know that it should be a string literal. If the string literal has the word world in it, then I'm going to report that diagnostic. So I'm going to create the descriptor that I had. I'm going to get the current location of the node. And then this has got an argument in it of 0. I'm going to say that string is too big a greeting. And that should, says, create a diagnostic problem for me. And all my other errors are coming up. And what a surprise, I'm going to shut down Visual Studio again. You'll open that up again. I swear when I get to testing, I'm going to show that this is the most painful way you could possibly test an analyzer and diagnose. And everything taking 3 times slower because I didn't allow for how much Zoom was going to take out of my machine. Yeah, there we go. Force the rebuild because otherwise it might take a little while. And what I should end up with is .NET Knots in here. And if not, I will go to my fallback. So I know this seems like quite a lot of work for what is essentially, I don't like that string. And you're absolutely right, it is. Like for this simplistic thing, it's a bit much. But this was just to show that actually you don't require an awful lot of code once you know a lot of the demos that come in. It's 3 lines in the initialize, changing the greeting was maybe half a dozen lines of code. And if it ever builds, it's going to be fine. So I'll show 2 examples of an analyzer while that's building, and I can't waffle any longer without going, no, it's just not going to work. I was really hoping it would kick in then. It'd be perfect timing. But yeah, I'll show 2 examples of an analyzer that you can have. So I've got an example project open at the moment. So one of my other Visual Studio installations. This is Slack.NET Standard. This is the Slack implementation that I've got. I have a natural analyzers project attached to this. And one thing I will do, which, come on, don't dive in. That I will show is that actually when you have a local project, when it's not a NuGet package, when you're maintaining this and you want your analyzers and your code in the same thing, it is something where you have to open the project file a little bit. And that's because you've got your analyzers and you've got a regular project reference. If you've opened up a CS proj file before, you've probably got used to that. These bits you probably won't, not so much. So private assets ensures that actually you don't become part of the build process and you don't end up dumping this inside your final output. Reference output assembly. So again, I don't want this as a reference for output at all. I'm using the analyzer when I build my code, but it's not part of my final project, and therefore it needs to be switched off. And you specify the output item type as an analyzer, so it knows that it picks it up. And what you end up with is in your actual project, when you open it up, it doesn't appear there, but actually in my analyzers project, you end up with the name. You open that up, and then you can see all the diagnostics that we put in that array at the bottom in the demo that says what the type of diagnostic is and what the error message is. Let's make that a little wider. The code's less important in this one. So now if I go for, a property of should serialize. So I use Newtonsoft in all my projects. And one of the issues that I had is that, for example, I have requester ID. So if I turn this into a string array, and then go to my error list. There we go. So I have a new code solution here. Slack.NET Standard valid array property requester is invalid. And then what I can do is go, okay, that's definitely going to be a list of string. Get rid of that bit, save it. Then it has go because all the lists have to be initialized, so I don't want people creating new lists. So that has to be initialized, that's fine. And then actually, because it's because the way Slack works, if you have an empty list, I don't want to create an empty array in anything. When it gets serialized out, it shouldn't exist at all. So what I have is should serialize methods. If anyone's not seen this in JSON.NET, basically, if you don't want to mess around with the JSON serialization settings, if you have a method which is should serialize and then the name of the property, it will actually use that to decide whether it needs to render the list or not. And if I get rid of that, then I should get another error pop up in a second. So it's recompiled, that now says the requester ID doesn't have that method. So these are the kind of rules that I've been able to put into Slack.NET Standard to ensure that if people are creating new classes, people are doing new work, I can make that happen for me. And they're all exactly the same. If I go into the analyzers and have a look at list usage check, the code's a little bit more involved, but essentially it's a property symbol. If the type contains a list, so if it's any kind of list at all, then don't worry about it. Otherwise, see if I've excluded it, because I mentioned that I want that attribute. Is it a JSON property? So potentially I'm ignoring it at a JSON level, in which case I don't care because it's the serialization that I want to worry about. I can have a look, see if it's a property, see if it's been newed up, and I run all my tests. But it's still at the bottom line, still just create the diagnostic, report the diagnostic. That's what happened. And so actually I'm able to put those rules in, and that's super useful for me as somebody running open source. And my demo didn't work, so I'm going to leave that alone. But actually, one that will work, regardless of whether or not I rebuild all my code. So if I turn this back to time one, not sure if anybody saw while I was building it. There we go. Actually had this pop up at the bottom. Demo 1 does not inherit from Diagnostic Analyzer. I didn't trust myself to be able to do the demos properly in front of all these people, especially people I work with. So behind the scenes, I ran diagnostic analyzers that specifically are watching my demo while I'm writing my demo. And in here, I have a little demo hints project. And this one has a bunch of .NET Dots errors in it. And it's exactly the same thing. And I've just gone, okay, if I'm working on demo 1, if the base type is still of type object, then I've screwed up. Tell myself that it needs to inherit from Diagnostic Analyzer. It's inherited from Diagnostic Analyzer. Check all the attributes that are attached to it. Does it have one that's called Diagnostic Analyzer attribute? If not, raise that one. And then keep returning, because what I don't want to do is flood all the errors and make it look like the code's crap straight away. But just give myself a little hint every time. Did I have a descriptor? Yes, I did. Got as far as initialize before I started getting a little awkward. And that's because my demo ran out and all my hints stopped. And I had to try and remember what it was from memory. But actually, quite liked it because it is an idea of one of the issues that you can have with people writing new code is that actually they don't know where to start. They're looking at it and going, I've got a class and it's a blank screen. How does this help? And actually, I loved the fact that I had a little demo guide talking me through in Visual Studio with little informational hints. Didn't stop me going, I'm going to go off piste and just do something else, because these are all informative. These are .info. It's not a problem. But what it did mean is actually I could start creating user guides that came out of Visual Studio and just ran in the background the whole time. So I tried to do it for all of them. I got as far as halfway through demo 2 and went, I'm actually spending more time on my demo hints than I am on my demos. This isn't quite right. So, but I really enjoyed doing it for myself. But it's just another idea. Actually, interactive user guides is something I'd never thought of for Roslyn analyzers, but it works really well. You want to start doing a code competition for a group of people to go, this is what I want you to build, but you want them to be able to go, give me a hint. Fine. Every time they put, give me a hint inside the text, it'll pick it up. And then you can start going, right, the hint is this. There's loads of little things. And this is why not just open source, but for private projects, it become really, really useful. So yeah, I just wanted to show that off a little bit because that was kind of cool. I liked that one. It was also a backup in case my demo didn't work, because it meant I could go, here's one I prepared earlier, and you've not, it's actually been working in the background the whole time. So analyzing diagnostics. So we've seen a brief example of those. We've seen some weird examples of those, including my demo hints. That's cool. The one thing I really wanted to do was this next bit, because that would have just made my demo perfect, but I really didn't have the time for it. And that's the fact that you can apply code fixes to these diagnostics. So that's the next thing. So if you are able to raise a diagnostic and say, this is the code for your diagnostic, .NET not 0001, whatever that code is, that means that you can create a piece of code and offer the fix. So if you've used Visual Studio, you're probably used to seeing the little light bulb saying you should do this thing. You are able to build your own code fix on top of your diagnostic and say, actually, I'm not only going to tell you it's wrong, I'm going to tell you how to fix it, because that's the bit that really helps. Going it's wrong is great. It stops the code getting in. But if you are a contributor and all you've got is Visual Studio going, your code's wrong, you're still going to have to raise that issue. You're still going to have to speak to me to go, your code is telling me that my perfectly valid C# is not going to get accepted. What the hell's going on? Whereas actually, you can create code fixes that do the same thing. These are all done through providers. The reason that that's really important, and that you mentioned what supported codes are valid, is it means that just because I've written a diagnostic doesn't mean I have to write the code fix. I can write the diagnostic and say the code is 001. You saw it come up in Visual Studio. Anyone can write a code fix provider for that, which I absolutely love, because it means potentially someone's going to write a fix that I didn't think of, or they're going to put the effort in and help your project in a way that you didn't think of. And so it's quite nice in the fact that you're not having to hack around with that code. Doesn't even have to be in the same project. is the fact that I support the diagnostic that comes up. If I come up with a better way of fixing your code than you did, I can write my own provider and it'll just come up as another suggestion. And that's how you get that list of suggestions when you start doing code fixes, because actually it's more than one came up. The code fix provider runs for each time there is a diagnostic, and you can just go register that action. But the big thing for me is the fact that if you select a code fix, we'll see in a minute, I'm going to go through, I'm not going to try and do it again, but I'll show the code for a code fix provider. You don't create an alternative to the code you pick. You pick an alternative to the whole document. So actually for something like the should serialize, which is what I'm going to show, where we add that method, I can have a property in line 3. That's the bit you click on, that's the bit. But when you look at the code fix hint, it goes, no, actually you want to put the method somewhere else. I can create a whole new method somewhere else in my document that still allows you to help that code out. You don't have to alter the code that generated the bug. You can create enhanced code that fixes the bug by adding to the document. I'll show it because I've tried that twice now and neither way sounded quite right. One thing that you are going to see with the code fix is I use a class called Syntax Factory. Saw it briefly the same idea when we were looking at analyzers. Essentially, Syntax Factory is the main class for generating code inside Roslyn. If I want to create code, do Syntax Factory dot, and it just comes with all the different types of node that you can create. I use Syntax Factory a lot. All my code is built with Syntax Factory. I'll show why it's not always a great idea, but I do it. I'll say quickly now, there are parse methods. If you've just got an if statement, all you want to add is 3 lines of code, Syntax Factory is quite verbose, and you're going to end up with a lot of, well, it shows here. All you want to do is test X. I've got to do a method invocation that has arguments, that has an argument list. An argument list is a singleton because there's only one of them, and it has an argument in it, and the argument has and just wanted test X. That's all I wanted. And so you can end up with quite simplistic code being quite verbose. So yeah, don't worry about the verbosity. We'll talk about that in a little bit. But with a code fix, I am trying to create a document to send back. A document is built of syntax blocks. So you can parse strings, but I tend to try and use syntax all the time. That way, when I get into more complicated scenarios, it's just a little bit more familiar to me. So I'm going to go to, I will go to my example now. Slack. So we saw the thing a minute ago where it complained about the errors coming back on that invite. So if I get rid of this requester ID process again, just to show you the kind of the way it's going to work. So that is Slack net standard should serialize. That's the code. It's only on my project, so I don't mind too much that I don't put numbers in. It's not a huge category where I have to start categorizing them that way. That's the code that I have to worry about. And when I click on requester IDs, after a second or two, it's pinged all the code providers and says, do you care about this thing? Yeah, I absolutely do. I should add a should serialize method. And I've said, stick the should serialize method at the bottom of the document. So now I have a code fix that puts in, the fix is nowhere near the code that I've put in. That just happens to be where the diagnostic is that's been raised. But the code fix can mess around with the document as much as it needs to try and help. Unlike the next bit we'll show, which is source code generators, code fixes are opt-in. So I have to click the button, at which point it will swap out the old document that was the one that had the diagnostic in it for the one that I've just sent back going, I would like this change to be made, please. And now down at the bottom, I have my should serialize method. So that's essentially what the code fix provider does. Again, if you're the one raising the diagnostics, that ability to be able to help your developer out by going, well, just add this. If you have a cloud standard where, for example, what's a really common one? Buckets in S3 or anything where you have blob storage must be encrypted. And they've written code and there's no encryption anywhere. It's all well and good saying this should be encrypted, but actually what's better is when they click on it going, and this is the code we're going to add for you and just fix it. Because the code fix works across all instances, when it pops up, you get all the benefits of having Visual Studio as well. So I can put that in and it comes up. And then I get fix all occurrences in this document, in this project, in the solution. I don't have access to those at the time, but what I will do is when it clicks it, it's then going to run that code fix provider anywhere it finds that scope and that code and just keep running until I run out of instances. So I can, when I put this in, I was able to fix all my code very, very quickly. I had more instances than I care to count of where I'd used arrays incorrectly. But it was great because it just meant I was the one screwing up and I actually fixed my own code by putting in something that was actually built to help others. And there were bits that I hadn't even thought of, like the events API. Suddenly I was converting them all to lists. So like, that's not right. Yeah, I messed that up. But actually looking at how many files it opened to try and apply the fix for me was a great way of seeing that actually this problem I thought was really small was really pervasive in my code and was a real issue. If I go to my list usage, and we saw that code with the fit, with the diagnostic. So it's a similar kind of thing. So where's my code? So where's the little list? There we go. So down here, I have all the diagnostics that I can fix. New list diagnostic ID. That's the wrong one, that's why. List usage check. Serialize. Array property to list. There we go, that's better. If I open up the right one, it's going to work much. There we go. Valid array diagnostic ID. So that's the diagnostic ID that I pulled back. And then I've got code up here. So actually I get sent a context, and the context, I can say, give me the whole document. And then I can say, actually, give me the diagnostic that you wanted me to look at and find out where it is. And then actually find the token in the document that is causing this diagnostic, which I know is going to be a problem because I know what this is. I'm building for the fix for it. But actually the bit that I want isn't the whole property declaration. It's going to point at the bit that has the property name. And so I'm going, give me the property declaration, the whole property itself. And then at that point, I'm going to create a code action. And code action is essentially the code it runs to then show you that little summary, that little bit for your code. And at this point, I'm starting to get a little bit more involved. And this is why I didn't want to try and write it out. Because essentially, I'm dealing with other concepts that I just want to make sure people are aware of. So I've said, get me the syntax root. So basically, give me the right top of the tree. And for me, I know that's going to be a compilation unit. I have a file. It is a C# file. So I know that in this particular project, that's going to be a compilation unit. Then get me the property type. So get me the list type that I'm after. And then create a new iList. So this is essentially taking the array type. So I knew it was, say, a string array. That's why I raised the diagnostic and going, actually, I don't want that. I want a property that's actually got a different type. It's actually the type iList. And then it's going to be an iList. It's going to be the same thing that the array was made of. And then I'm going to take this old piece of code and I'm literally just going to go replace the property that you've given me, which is the array type, with one that's got a list in it. And I've got my other bits here, which are using statements, because what I wanted to do is go, actually, the other thing that you need to worry about is if this is the first time you've put an array in, you're not going to have system collection generic in there. And so you're going to write code, it's going to put the code in, it's still going to blow up because you're using statements are wrong. But I control the whole document now. I don't just control that property or just that class, I control the whole thing. So I go, actually, if I don't think you're using, if you've got the right using statement in there, I'll pop that in for you as well. Took me ages to figure out that was what was missing. Really annoyed me. But it was a tiny little bit of code that just went, yep, I want to put a using statement in there now as well. So suddenly you're starting to build up. You're not making the user have to figure anything out. You're going, look, I'll tell you what you should have done this time because I told you it was wrong in the first place. And actually then next time, maybe you won't have to. Or more accurately, I then write code for my own solution, forget this is one of the rules, and I break my own project and wonder why it failed, which is kind of how I use this most of the time. And there's a little property there about the batch fixer, which is basically how do you fix all when you press that button, say fix everything in. It's a regular provider to go around and run this each time. So there's a lot of code there. And I don't want to go into it all. You're seeing a lot of Syntax Factory stuff. And actually, you'll see that Syntax Factory, this is one of the first ones I wrote because it actually has the word Syntax Factory in it. These lines can get quite long. One of the things that I do, I'll show, I'm going to load the right project now. one of the first things I do now in all my others. I think I've put it in here. Yeah, zoom out the way again. So I'll put this in. Global using, if anyone is a .NET developer and hasn't seen this yet, if you want the same using statement in every part of your project across the board, this is absolutely wonderful because you write it once and it will naturally be assumed in every single part of your code on that project. So I give it an alias, give it a 2-character alias because I am writing it a lot and these strings are huge. And so suddenly my code becomes, I go into code-rich provider, I end up with sf.literal expression. And when you start getting really big on something like some of my Slack stuff, that becomes sf.qualified name, sf.qualified name, sf. All of a sudden, these strings become really, really small and really concise, or as concise as they can be when you're using Roslyn. And it just becomes a lot more readable because you're worrying less about the word syntax factory, which, to be honest, after a while just blurs all the words together. And actually, you just start worrying at the bit after it's as small as it can be without like losing its identifier. So a global using can make a lot of difference in making this quite compact. But that's how code fixes can work. I'll go back to my presentation. Where time as well. Cool. Yeah, coding standards, Slack.NET standard is a big one for that. The other thing I wanted to mention, I'm going to run a little over if that's all right, Pete.
You've got
Yes, now I'm aware of that. The other thing I wanted to mention though, and the thing that is on a night and day in terms of functionality is source code generators. So this is another hook that you can use in .NET Roslyn. And as the code says on the tin, they really did do very well with the naming on these things. Generate source code. But more importantly, generates code to the existing project that you are compiling. So those of you who have used T4 scaffolding templates for things like MVC, ASP.NET, you might have had projects where you've got a template and then it goes, yep, I can type in some variables, hit a button, and it will auto scaffold some classes for me. It'll sort that stuff out. Source code generators are kind of next level because what they do is go, I know all the code that you've got at the moment and that you are compiling. And based on that information, I'm going to let you add whatever extra code you want, and you can just build that in real time. And just before the compilation actually finishes, we'll run all that code in as well. Now, that sounds like a kind of cool thing to do. And the first thing you do is go, great, I'm going to write this one method and I'm going to hit compile, and then it's going to put all this other stuff in my method. Source code generators can't change the existing code. They can only add to your compilation at the moment. So you tend to kind of go, okay, that's not great. Obviously, what I want is to add to all my existing code. That's how it works. And so what really helps out is that you have partial for the win. Not sure if people have used partial classes. You've probably seen them quite a lot. Again, certainly anyone who does like Windows Forms, XAML app development, WPF, that kind of thing. You'll have partial classes because the XAML code generates into the other part of the class. If you have a partial class, your source code generator can go, well, you write that bit over there. I'll write this bit over here. I'll write the other part of your partial class and I'll fill that in. A slightly newer piece of language functionality is you can have partial methods. So you can put a method in and say, actually, as long as it returns void, you can have a method and it can be partial. And then you can decide whether or not your class completes that method. So that's quite cool because it means that you can write a partial method here and then your source code generator can decide whether you care or not about that method. And if it does, it can fill in the rest and it'll create the partial method for you as well. So with a partial class and partial methods, you can suddenly then start to build quite expansive code base that's not really there at all. Certainly when you commit, what you commit is your one class and your reference to a source code generator. I'm going to show an example of source code generator. It is much more involved. You are going to see a lot more syntax factory, and I mean a lot more syntax factory. So I just want to kind of explain why I decided to do syntax factory. And syntax factory is starting to mean less and less as I say it over and over. Basically, the issue was I did originally start with strings. I just had bits of C# code and went, yep, that's the thing you want to dump in. That's great. And then I said it and went, right, well, occasionally I've got an optional base type, and occasionally I've got some code in my partial method, and occasionally it's asynchronous, but occasionally it's not. And occasionally I've got a mapping type, and occasionally, and I did all this and I got all the strings, and then the compiler came back and went, you've got an extra bracket somewhere. I've got 25 constant strings. I've got automatically generated methods, and one of them had a bracket wrong. And I was a little angry at that point. I must admit, I didn't look at Roslyn for a few days. But essentially that was the problem, was that actually Syntax Factory, although it is really verbose, once you get used to it, it meant that I knew that it was generating code that could work with other code. When I refactored my method, it wasn't, well, I'll cut that string out there and put it in its own string and then reference it in that string and that string. When you're trying to do simplistic stuff, parsing is great. Absolutely do it. The .NET team on AWS have got a NuGet package called Lambda Annotations, which helps you hook in requests and responses into AWS Lambda. Looked at the source code for that. It's all bits of string parse, because they're putting like 8-10 lines of code in, and they've got a little bit for async, but that's about it. And absolutely works for them. When I do my Slack stuff, I've got 5 base classes. I map object models to object models. So I'm doing mapping code. It gets really complicated really quickly, and I needed to be able to refactor that quite a lot. And Syntax Factory let me do that in a way that felt very comfortable for me, because it was just refactoring code, not trying to slot strings together. So I'm not saying Syntax Factory is the thing that you should do. And in fact, if you look at most of the online tutorials, they'll point you at strings. I'm saying once you get to a level of complexity, you might want to look at it and see just how more comfortable that makes you feel with large code bases. So my source code generator, Slack, there we go. Right, I'm going to get rid of this. I'm not expecting to go through a lot of this code. This is a lot of Syntax Factory code. It really is. And this is one of my classes. This is probably one of my bigger ones. This is the marker buildup, yeah. But I've got the bit that writes the application. I've got the generator itself, which is the bit that really I care about. And I've got lots of other classes, and they all do stuff, and they're all using Syntax Factory everywhere. And there's lots and lots of code. The reason why there's lots and lots of code, though, if I open up the example application, this is my class. So I use marker attributes. I really like them. It's a technique that I feel very comfortable with, because for me, it's quite explanatory to somebody who's coming in for the first time. I have got a Slack application. I've got a method here that responds to an event. I've got one here, responds to a slash command. If you haven't used Slack before, when you do a message, you do / and then a name. Behind the scenes, that pings a URL, and you have to deal with that in your code, and then you send the response back. I've got 1, 2, 3 lines in 3 methods and 4 attributes. So it's relatively small. Behind the scenes, if I open up my analyzers, I've got my Slack net standard annotation. In the same way the diagnostics came up, when you have a source code generator, you open that up, it shows all the kind of all the source code that you've added. I open that up. The reason that I have a lot of Slack Factory is because it's generating a lot of code. It's generating the other part of my example class. It's creating a pipeline, which is an object I'm using from another reference that's been added. It's initializing all of them and making sure that they all reference this outer one so I can get out of the methods. I then have inner classes. The inner classes are a particular base type maps. I have arrow methods that cast, and they can cast because they're the only argument in there. I've got slash commands that do something else. I've got all this is auto-generated code. Like this is just done every time I change something. Every time that has moved forward, I've got another class. And then I've got 5 constants, which are the execute methods that allow me to do this. From my point of view, the amount of time it takes me to build a Slack application is probably a couple of hours. And like I wrote the library, I know how this stuff works, but putting the wiring in is a huge deal. Having a source code generator just come along and go, don't worry about it. I'll sort all that out for you. It's not a problem. Is absolutely fantastic. Another example I had, and actually I'll open this one as well. The first example I had, Alexa.net is my Alexa skill application, and had a bit of a not a problem, but this is why I started Roslyn in the first place, was I'm really proud of everything we do with Alexa. We have dozens of NuGet packages you can hack into any part of the Alexa ecosystem that you can with a regular programming language that is supported by AWS. I really, really like the work we've done. Someone wrote a beginner's guide to using the library, and it was 10 screens worth of instruction on setting up a basic Alexa skill. And most of that was using our library. You have to do this, you have to put this if statement in, you have to do that thing, you have to do that. Then it has to work this way, then it has to do that way, then it has to do. It was disappointing to have something that we were so proud of not work the way we wanted. And so we ended up, see if I can find my example on here. I've put it somewhere else. But actually, I ended up writing, oh no, there we go. My example skills kicked in. So again, I have here an Alexa skill. Normally, if you're dealing with Alexa, you're using AWS Lambda, but I didn't want that to be the only way. So I've got two source code generator bits coming here, one that creates the skill, one that creates the Lambda class. I'm going to keel over for a second because I'm now running a 4th instance of Visual Studio. So, come on, Visual Studio, work with me. There we go. And again, I've got a few bits here. So I've got a launch. It's just rock, paper, scissors. It's nothing particularly taxing. So you launch it, you've got to play a game, you've got to help. But actually, when I open up the source code generator, not only does that do a very similar thing to the Slack one does, that it creates all the work for you, but, oh, wrong view, come on. Oh, why is that giving me class view? Because that opened the folder and not the solution, I think. Oh no, there we go. Analyzers, done it. Done it. So actually, this is creating multiple files. So it's to show that you don't actually have to create just one file. So I've got one partial, which is the skill. So this is a very similar code. You've got a pipeline, you've got all your inner classes, you've got all the work. Here, I'm actually doing quite a lot of argument mapping. So if you say I want if there is a parameter it doesn't recognize, it assumes that it's one of the variables that have been passed in by Alexa, maps that for you automatically. But then I've created a second one, which is the Lambda code as well. So this is using some of the work that the .NET team have given us now in .NET. You can use top level, you can create a static main, and they've created a Lambda helper that hooks this in. So you give it a request type and a response type, and it bypasses all the reflection code, puts that straight in. And then I use a couple of methods inside all my auto-generated code that's just static. So separate to the dynamically generated code, you can also just dump code and go, and I want all that as well. And you can do that just before the compilation work. So I've got a helper class that I put in that does a lot of the work for me. But this is a fully working AWS Lambda with essentially the bit that I commit to code is my rock, paper, scissors class. That's what I commit. But everything behind the scenes still works. It's a natural part of the publish to AWS Lambda. I absolutely love the fact that I can help people. Now the tutorial is add this NuGet package, put these two attributes at the top, and then start building your skill. That's our go-to guide for a how-to on how to start an Alexa skill because of what we've been able to do with source code generators, which I absolutely love. So I'm aware I'm a little over. So that's source code generators. They are, like I say, you can get right into them and they are quite complicated, but when you get them working and when they can save so much time, it is a phenomenal thing to be able to see how quickly people are able to build these things. And the last thing I want to mention, just because it's been so difficult opening and closing Visual Studio on my little laptop, is the testing side of things. So testing diagnostics and code fixer analyzers. Actually, if you start a new Roslyn, make sure I've opened up the right package. No, I haven't. Where's the example? There we go. If you create a new Roslyn analyzer project in Visual Studio, you get a lot of this out of the box. It will create a test class for you. You get some analyzer and verifier classes built in. I've made some small tweaks to mine because normally you don't have analyzers analyzing analyzer code. So it's a lot. I had to tweak a little bit there, but essentially what you end up with is you're able to simply go, I want to verify that given this code, and I've just got a little utility method that dumps the C# file in, I will receive this error of this type in this location. That's my code. And literally it just appears in the test explorer and I can keep running. So I was able to, for my demo, go, well, at that point, I should have the issue about the fact that I'm not inheriting the right class. At that point, I've got the diagnostic analyzer and I've got stuff in, but I don't have a descriptor. So make sure it raises that one. At this point, no initialization. At this point, if the initialize method has a throw statement in it, raise an error, make sure. So you're able to just create bits of C# code and go, yeah, if you run that code, I expect this error in this place. And then that just keeps you nice and consistent. With source code generators, it's a little bit more intense. It can be a little bit more expansive. Personally, and this was from a guy called Andrew Locke, who did a lot of work on source code generators, did a great set of articles about it. Thoroughly recommend looking him up. I use I open up my analyzer. I use a package called the Verify. It's got an extension for source code generators that are built in. It does something called snapshot testing. First time I've ever used it. But what you're able to do is essentially you say, well, here's my code. So here's my event handler code. That's what I'm testing against. And then the first time you run it, it goes, nope, that failed because your source code generator produced all this code and you haven't given me anything to compare it to. And so what you can say is actually for that example, response to event, here is a verified version of the sample. This is what the source code should look like when it's finished. And it will just keep rerunning. And if the test fails, it automatically opens it up in Visual Studio Code and gives you a side-by-side view. You can go, this is what your source code worked on. This is what you told me it should look like. Here's the diff. And it opens up the diff in your default diff tool, which for me is VS Code. And it's a really fast way of just iterating through that code because I end up with, again, my tests are actually really small. My snapshot tests are just, I've got one, read that C# file and then verify it. And actually what will happen behind the scenes is certainly for mine, because I've got multiple files in the snapshots folder, because I'm telling it to use the snapshots folder just to keep these clear. You end up with the name of the test, then a hash, then the file you're generating, and .received and .verify. So the one that it got back and the one you expected it to do. So you're expected an actual, and it just compares those two files and works that each time. And what that means is you can just keep hitting run and going, no, it's still not quite right. No, it's still not quite right. No, it's still not quite right. And just keep iterating through it. And because it's all inside your test cases, you don't have that awful shutting down and opening up, doesn't cache anything. Certainly with the analyzer one, the tests are an absolute godsend because otherwise it can take you forever to just get a very simple analyzer working. So thoroughly recommend creating a test project and getting that up. But yeah, snapshot testing, when you're getting through, certainly like I am, I was getting some really big examples. It meant I could start getting quite adventurous. And like these started out with just, it was an attribute and a message. And then I started putting more in, then I started doing weird combinations and I can just push them in because then that way. And if it breaks and it doesn't produce anything, you end up with blank files. And it's just, okay, nothing is definitely not what I expected. So there's something fundamentally wrong. I broke something big then. And you can go back to the beginning. So yeah, I'm a little over. Talked about analyzers a little bit more than I thought. But that is me done. So are there any questions?
One in the chat.
Yep.
Near your well, I lean in there, see if you're in the way. Hold on. That's really not helping.
Oh, okay. Good.
Somewhere around there. Oh no.
There we are. I think it's done.
I'm wondering right now, so Stefan Poltz,
Yep.
remote, has asked, I'm wondering right now, how could I find out whether system.collections.generic is available as a global using? I guess not syntactically, but only semantically.
Yes, because you would need to. That's an interesting one. Yes. Yeah, because you do have access. It's worth mentioning at that point that, yeah, although I showed syntax because I inherit from a class called incremental generator, which means basically if given the same input, it produces the same output, which makes the whole system faster. So I tend not to get access to the compilation as well, but you can use the compilation provider that's available in a source code generator to go, actually, do you also have this? And look through all, you can look through all the syntax trees in the project and go, do any of them have ... that would be particularly painful to find a global using at that level. Because yeah, I tend to go up the tree and say, is there a using statement? But you're absolutely right. If you had a global using, you can look through all the syntax trees and have a look for that type of statement, or semantically look through all the code and see if there is a global using. The issue with trying to do anything at the semantic level is it does require more overhead. So you're possibly going to get a performance hit. But at that point, I'd say you're probably right. If you're thinking global using is something you absolutely want to pay attention to, then it's probably worthwhile. Because yeah, then you could look at the global using name and go, actually, I will use that global using instead, or I don't have to worry about it. So yes, it doesn't have to be semantically, but if you do it syntactically, you're basically searching through all the code it's about to compile, and that's no small thing. But I see myself testing that in the next couple of weeks now. Because yeah, that's a really good example. I really like that. Thank you. No, especially as I do have code that's analyzing my analyzer, I'm going to want to see how I can check the syntax factory, that using statement, because actually that should be something it should highlight in my code. So yeah, no, I'm definitely going to try that.
Any questions in the room before you ask? There is, if you can repeat it. So. Looks bamboozling them.
It is worth saying Roslyn is not it's difficult to get started with. Certainly I found that I had a use case that I wanted to specifically make. I didn't like the fact that in my head I'd screwed up my code, and I wanted to make a way of making sure my open source code was easier to contribute to. Also, I prefer writing code to documentation, so it's better to write an analyzer than it is a readme. But I'm aware that I shouldn't think that way. I think that was the first. Sorry. Oh, Jesus. Okay, well, I'm aware that someone else had their hand up, so let's just try.
It's been right to this question.
So the question was, is my demo code available online? It is. I have a sneaking suspicion I kept it as a private repo while I was desperately hacking around with it 2 days ago. I'll make sure it's public at the end of the talk. But if you go to, in fact, I'll do it while we're on the talk. There's no reason why not. There's nothing you can't see. Just do EVP. Yeah. The repos. There we go. Yeah, it was talks.roslyn demo. Yeah, let's make that public. There's no reason why it shouldn't be.
Not more the keys.
Yeah, I'm not going to get a denial by wallet on this one, so I'm okay. If I can move Zoom out the way again. Oh, Jesus. Sorry. Change visibility. There we go. Change to public. Cool. I want to make sure I've read and understood these specs. Okay. While I'm answering more questions, I will do this because that's going to annoy them.
Any more questions?
Cool. Yep. And actually, I've got, again, if I'm doing it live, I might as well do it live.
The YouTube recording will be as well. So
Yeah.
Please, because yeah, there was a lot.
Yeah. This is the one that I used to start off with, creating an incremental generator by Andrew Block. Really, really good talk. Specifically because he was helping me figure out the marker attribute problem, which I haven't implemented everything he put in. He goes to a great length of detail, but it was also, I think it's a slightly different set of posts he's done that mention the verify library and snapshot testing. But certainly, yeah, I've used Andrew Block for a lot of my stuff and from source generators and incremental generators. But yeah, so if you want to start off a 10 on some of this stuff's really good. Oh no, it is that one, part 2, incremental generator with snapshot testing. There you go. So yeah, I nicked a lot of the ideas from here where I got stuck and went, no, I have no idea. So, and there were a lot of that. So it is an area that involved the simple stuff is done really simply, but there is then you hit a curve at some point where complexity becomes more of an issue. And that's why I started working with Syntax Factory so much, because yeah, I found that strings didn't quite cut it. But Andrew Lock's stuff is really, really good as a starter resource. So he goes into a lot of detail. They're quite lengthy articles, and he explains a lot about why he's doing things behind the scenes and kind of why there are performance issues with the old way of doing it. Source code generators have been around since I think it's .NET 5, and they were very resource intensive. So on a little laptop like mine that can only handle a few instances of Visual Studio and Zoom without dying, certainly you suddenly start getting warnings in Visual Studio going, yeah, this is going to degrade performance if you use it. The stuff they've put in .NET 6 and .NET 7 for incremental generators makes that a lot more performant. And it means that that testing cycle is really, really fast. So you can feel like you're really being productive with it.
By the way, it's free. Now three. So pretty high.
Yep. So sorry. So the question was, how do you debug the diagnostic analyzers? Like I say, this is why certainly if you're creating a new diagnostic analyzer, please use the Visual Studio template, because what you'll get is a nice test in there. So assuming this code still runs with how much I've messed around with my stuff today. So this test is using demo 1 basic, and literally you just go in. That's going to be demo 1 hints, yeah. And I can literally just put breakpoints into my code, because actually behind the scenes, what that's doing is creating a new .NET Roslyn workspace, adding my source code to it as a what it calls like a test0.cs file, essentially with my source code, and then running that source code. So when I attach it to the debugger, it attaches like it would any other application. So debug, I think it's demo 1 basic. And hopefully what will happen is that will be okay. This is where I find out it's a completely different test and I've just attached the wrong one. But yeah, so the classes that it builds with and the Roslyn API comes with a bunch of test classes that help. Same with the code fix provider as well. When it runs that, you give it 2 source codes. So you give it the one that you know is going to cause the problem, the diagnostic that you're expecting it to raise, and then the fixed version of the code. And it automatically runs the first one, checks to see if the diagnostic exists, and if it does, automatically applies the code provider as well. Yeah, I've picked the wrong bug. But yeah, so you can literally just attach to a test and then run it that way, and the debugging works just as well. So same with source code analyzers. It's because I use the verify and the snapshot testing. You run it and then you compare and contrast, then run it, compare and contrast. So it's a more iterative and less interactive process. But you can still attach the debugger. You can still hit F9. It's just you're then pausing and then you still get the output. So in that instance, make sure you're looking out for Visual Studio Code updating in the background. Because a couple of times I've gone, brilliant, that passed, it's fine. And actually I didn't notice the little VS Code warning that a new diff merge had been loaded in for me. But yeah, they all work with the debugger. So I was trying to use Visual Studio purely because I wanted to show the interaction the user gets from open source, not that as a developer, that's what you do to test. So yeah, there is always a way of getting a debugging experience out of it. Cool. Go on then. Yeah, one more. Overall, because these rules aren't, well, they are arbitrary, but they're not dynamic. They don't change very often. It's a one-off. I think it's more, yes, there is more time involved in a source code generator than a paragraph in a README file. I think for me, it's that return on that investment. As an open source maintainer, I love writing code and I love playing around with stuff. So writing code to help people isn't work. Writing a README file with the rules in it and trying to explain it properly, it's hard. Don't like writing documentation. I'm not good at it. I wish there was somebody who was. So I would rather spend my time banging my head against a bug for 5 hours because I wrote the analyzer wrong and then get that rush of, yeah, my code works and I've helped everyone else. In terms of the contributors, you are the maintainer to your library. The first person you help by writing an analyzer and a source code generator is yourself. I maintain Slack apps for my library. Biggest issue I have is creating demo apps to make sure that I can raise the issue that caused the thing that was making my library not work. If a source code generator generates 90% of that, so I can write 4 lines of code and go, and then build all the other gubbins around it that I get annoyed by every time I have to create a new demo just to figure out what the bug in my code is, I'd rather do that. So yeah, overall, you end up with a larger code base, but I think actually on balance, you end up spending less time maintaining your code because of it. This stuff doesn't tend to change very much. Once your code fix works. At some point, someone's going to use it in a way you didn't think, and it's going to blow up, and you'll have to tweak it a little bit. But that's essentially, that's a small price to pay for the half a dozen times where you've gone, oh yeah, I forgot that I was the one who wrote that rule, and now my own code is telling me it's wrong. Yeah, thanks for that. So yeah, it's a good question. But yeah, I think actually overall you end up, you spend more time doing what you enjoy if you're anything like me. So.
More question? Good question.
Yeah, brilliant. Thank you. Cool. Okay, so the question was, do I think this is useful for mapping things like protobuf, where you potentially have serialization standards that are a little different? Actually, I think I either skipped the slide or didn't notice it, but actually for source code generation, anything that does mapping to and from, absolutely source code generators is a great one for that. Primarily because .NET's notorious for anything that does mapping being reflection based. So anything where you might have gained by using protobuf, you then end up losing because you're having to do reflection on the types and going, well, actually, I know this should be this serializer and this serializer. And then you end up caching and blah, 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 and your library gets quite big. Yeah, anything where you can map code to just go, no, write this, then this, then this, then this, then this, then this. And that's anything that pushes it to the left of your development pipeline. So it's closer to code generation and less to run. Basically, it's compile time rather than runtime. And protobuf's a really great example where actually you can write optimized code for a thing that can change anytime somebody submits an update, and you don't hit a lot of the problems you'd have by messing around with that at compile time. So mapping is a really good one for source code generation, absolutely. And yeah, anything where you would normally worry about reflection, which is normally a mapping thing in my experience, then absolutely source code generation just doesn't get rid of the complexity. You still have to check a lot of stuff. You're still writing a lot of complex code, but it's complex code to generate something that is actually quite clean and ends up being fewer lines of code much faster. And certainly where, obviously, if you're using something like protobuf, you want that performance of being able to serialize and deserialize very, very quickly. Having to then stick a bunch of reflection in the way kind of ruins that. So yeah, source code generation is a big win for anything where you're doing mapping. And actually mapping's the next thing on my list of Slack have a standard for the way they produce UI and the way they respond back. And I don't like the amount of code I have to write to maintain that. So yeah, I'm going to use source code generation for it. So yeah, anything that involves mapping from one to another, I think source code generation is definitely something you want to look at. Yeah.
I've got a stupid question.
Cool.
What about AI-driven source code generation, Copilot? How does that, do you think, fit in? Because you've had to do a lot to make that work.
I think the fact, okay, sorry, the question was using AI and dynamic source code generation compared to source code generators. And that's going to hurt my head a little bit to come up with an answer. I think the fact is that AI is guessing what you want. And the whole point of trying to put the kind of thing in that you're dealing with Roslyn is, I know what I want. I'm not trying to ask someone to finish it for me or a computer to help me finish it. I'm saying this is actually non-standard. This isn't .NET code. This isn't just finishing off my function or taking a common scenario, because if it was, I'd rely on .NET giving me the errors. And actually, as a side note, one of the things that I found certainly with Roslyn is I ended up accidentally writing code that the .NET compiler could have handled. Like making sure it must be of this type. It's like, doesn't matter. When the code compiles, it's not going to be right, and the type checking will kick in. It will come up with its own error. Don't do it. So you will repeat yourself a little bit when you're starting to learn. I think the difference is that if you're creating an analyzer for an open source project or an internal project, that's a specific rule that no one else has written because it's your rule for your code. And therefore I think AI is trying to solve a different problem, which is we want you to write the code faster, not we want to guess what your arbitrary rules are that you're trying to enforce on a bunch of people that you've not written. There is no basis for comparison of my rules for my NuGet package. So I don't think it's quite the same problem. I think they both speed up development, which is a good thing. And anyone who can help speed up development is going to be on a winner. But I think they're answering very different problems.
Yes, I'm referring to Alexa.net. I want to do this in less than 16 pages of documentation, please, create your skill. And can you program against that? You reckon there's some paradigm there where instead of you having to write all of that, or maybe you could write it in a way that is less verbose?
I think the problem is, again, is that the bit that I'm automating, I can only do because the user of my package has tagged their thing to say, I want to do X. I know they're trying to create a particular kind of handler for a particular kind of output. Doesn't matter how good the AI is, you're going to end up in a position where it won't be able to quite finish it in the same way. An AI generator would manage maybe half the code because it would know that there is a common model for the method interface and potentially for some of the code in the middle. But a lot of it is based on your information. Like the protobuf, for example, it's like, yeah, you could help me write protobuf code, but my model wants to serialize that way. And I know that that standard is going to serialize that way. So actually me tagging it and going, this thing should be treated this way is more likely to get a consistent benefit. So yeah, I think there is a small overlap, but I think they're fundamentally different questions. And that's why they sit so well side by side. I'm not saying you wouldn't use source code generators because you have AI generators or vice versa. I'm saying that when you use them both together, you're producing a lot of code very quickly. Yeah, which is essentially what everyone's trying to do, is help get to production faster with good code. Yeah. I don't know, no such thing. Yep, so the question was, is it possible to package these up? And actually, with my annotations libraries, I can show you that it absolutely is, yeah. Because they need to be added. So the .annotation extension was a nod to the AWS Lambda team who created Amazon.lambda.annotation. Basically, the fact that you're annotating your class with attributes. But essentially, although I'm using local projects all the time as my example, go into the project file, what you'll see is, some extra bits and pieces that aren't normally kicking around. There we go. So you've got all your references that you normally have, package references for NuGet. What I have here is private assets on my package references. Basically, what that means is, although I'm going to allow this to be part of a NuGet package, I don't want anything that consumes this NuGet package to have that as one of its references. I'm going to use Amazon.lambda.runtime support because I need stuff in that assembly to generate the classes I need and to do the work that I need to do. But I don't want the consumers of my package to have it. So basically, if I add this in, what I should find, and actually I bet you any money I've accidentally added it. Yeah, it's not going to come up because it's an analyzer. But when you build it, request handlers will be part of your NuGet dependency because I am building code that relies on it, but this doesn't. But then what you have is here, you have an extra bit of code that says actually the output of my DLL, when it's packaged, goes into analyzers/.NET and then the language name. What that means is that you can then, I'm pretty sure, depending on the Wi-Fi, I'm going to do, this is where I find out whether or not I actually publish this stuff. But yeah, so I can then go Alexa.NET.annotations. No. It is, because it's in my little thing. This is where I find out. Too many of them, and I need to find annotation. Yeah, I'll find it in NuGet.org and that'll be fine. Yes, you can. And then you publish it like you would any other NuGet package and you make it possible. It's purely the change to, there we go. I knew I'd produced that, I just didn't pop it up. But yeah, with sample README and everything else, so the stuff that I showed you that builds behind the scenes is absolutely deployable. Yeah. So all you have to do is if you want it to deploy as an analyzer, you literally just tweak the project file so that it comes back and it says, actually, when you package this up, don't package it like a NuGet extension, like a package reference, put it in the analyzers bit. And then, yeah, as soon as you add it in, it'll naturally become part of the analyzers. It'll cache it, relies on the version number to update. So it's all the usual NuGet goodness of being able to produce new versions or add new analyzers, and it dumps in. Oh, that's a side effect that certainly if you don't use the project, please make sure that you use the target framework as Net Standard 2.0. You'll get really weird NuGet references going, I don't know, I can't use version 6 of system collections immutable or other bits and pieces. Certainly source code generators, the incremental generator needs to be Net Standard 2.0. You will get weird compilation errors for no reason that you can possibly think of if you don't do that. And then you tweak that bit and it all works. It's great. That's another 3 hours of my life I'm never getting back. But yeah, Net Standard 2.0. Doesn't matter what language of C# you're using, but Net Standard 2.0. Yeah. So yeah, you make the small little tweaks. I've got some extra bits here because of the way I'm dealing with my resources. So, because I wanted the runtime support to work a little differently if I had one of my attributes in. But yeah, absolutely. NuGet packages, dump them out and give them to everyone. So yeah.
Any more questions? These are great questions, by the way.
Yeah, this is brilliant. Thank you.
Obviously, as far as I am aware, beyond the pipelines. So that's one of the on the front.
So the question was, is it possible to use Roslyn analyzers as a code quality gate with pipelines? My immediate thought is because this is hooking into the compilation process, if you're raising a diagnostic, it can then be a quality gateway because you have the same rules as you can remap any code ID. Like once you know what the diagnostic ID is, you can actually treat this as an error, regardless of if I've produced it as a NuGet package and given the fact that I want lists and strings as info rather than anything that would actually stop a pipeline, you can still remap it and say this diagnostic ID is treat as error. In fact, I've got something in my code that does that by default because there's a bunch of errors. If I put it in, where is it? It's going to be in my verifier, I think. Okay, I thought I'd find it fast. Yeah, there we go. So actually, when this is part of my test, so like I said, behind the scenes, it's running a proper command, running a proper compilation. So actually, to ensure that it fails my test, I'm setting all my hints, which are informational, as report diagnostic.error, which means I'm not messing around with what was packaged. Like it doesn't matter how it's sent. You can still make sure your pipeline fails if a particular error type is coming back, because you can treat it as an error. So it's an instant like failure and that. So certainly for analyzers, I'd treat it that way and go, yeah, just remap them, make them more important than anyone thinks. If you want to ensure that that's your quality gateway, then use warning and errors like they should be. And yeah, and you dictate that. Essentially, although we're giving a suggested diagnostic level, you control your compilation, you decide what actually matters, and then that can become part of your pipeline. So you can fail if it comes back with anything of those hints and do it that way. And that would be like my first port of call is, yeah, start messing around with the compilation options and mess some people up when they look at Visual Studio and go, no, these are all info, it's all fine. And then your code build fails because of it. So, but yeah, I put it in here because the default code for Roslyn fails on warnings and errors. And I was using infos. So it went, yeah, there is an info, but it's not really a problem. And I wanted it to ensure that it definitely failed. So I added them in here. So, yeah.
I'll go to the questions in the chat.
Yep.
I mean, having a bit naive in this respect, if you've got code quality across an org, that's everything. How do you deploy that so that, say, I start at your company and now everything I ever do goes through those same gates locally, throws up errors rather than warnings to say you can't even compile your code without actually writing it properly, you know?
If you're doing it locally and it's not already a warning or an error, you can still do treat warnings as errors. Those error information can still be mapped. I can't remember whereabouts in Visual Studio it is, but you can alter the diagnostic at the local level to say treat this specific error as. So
Okay.
although you're seeing them as compilation descriptions here, you can make it part of your VS setting.
Is that something you can push down?
The package settings can then be exported and imported in, so
Oh,
you can do it that way. So, and certainly if you're using something like ReSharp or anything like that, then that's made a lot easier as well.
Next, how does that work with something like code spaces? Can we get that to work all through that?
Okay, sorry, the question is now code spaces and diagnostic analyzers, and my head hurts.
This sounds perfect because it's all there.
Yeah. No, absolutely. At that point, I think you potentially, I'm sure there is a way, but it's not one I can think of right now. So in my head, I feel like there should be an ability to go, well, actually, the project must have this package attached to it to be considered valid. But I'm not sure how you'd do that off the top of my head. So yeah, answers on the back of a postcard for that one, because that sounds interesting.
Right, I'm going to try and make this work. It's going to be a lot of muting and unmuting, but Stefan, you have a question, so come off mute. and
Yes,
ask it.
I really love the idea of using an analyzer in order to guide you for the demo. I want to ask, how did you get started with Roslyn in general? What were your resources other than the blog post from Andrew Locke you mentioned? How did you learn all of this?
Ask that again. Sorry, Stefan.
Excuse me?
We're getting
Again, Stefan.
Okay, trying one more time. What was your starting point in learning Rosling in general?
okay. In general, it was the article that started me off as this is how to use the NuGet package that I'd spent so many hours and months building. But I realized that I started doing source code generators to start with, and realized that that was a mistake. So yeah, I very, very quickly started using MS Learn tutorials to do the like literally my first diagnostic analyzer, and actually the MS Learn stuff for the really basics was great. Code fix provider was a little bit more complicated, and suddenly I realized that actually maybe the MS Learn was not quite great for me. But yeah, once I knew the basics of the diagnostic analyzer, I then just started Googling. Andrew Locke helped a lot. Moving through that stuff with the diagnostics. A lot of it was rinse and repeat, like just going through my own code and trying out. I've been messing around with diagnostic analyzers. I started actually at a previous .NET Knots. There was some lightning talks going on and I was messing around with it that night. And that's where the idea of this talk started. But yeah, it was literally just there must be a faster way. And I started delving in. I knew I'd heard of Roslyn, but it wasn't something I'd tackled before. So yeah, it was literally just MS Learn and then Andrew Locke stuff, and then a lot of just trying stuff out. But the idea of using an analyzer to help me write an analyzer for a demo, that was about 3 days ago, which is why. So I've had an interesting weekend. Yeah, my girlfriend didn't like me very much for a bit, because all I was thinking, like, are you thinking about something? I'm like, yes, I am. I'm thinking about code. And how to write this next hint. But yeah, it was purely the fact that I was like, I don't think this demo is going to go well. I was really worried. It's the first talk I've done in a while. I'm like, if only I had a way of generating something that could tell me what the next step was in my code. And it's like, well, the whole bloody talk is about that. So yeah, that should be easy. But yeah, and then I just got a little lost in writing. Like, it was very meta, writing analyzer code on analyzer code. And weirdly, it came up with some problems that I wouldn't have had otherwise. Like the tests didn't work, because I had NuGet package references that weren't in there, because it wasn't expecting me to look at analyzer code in an analyzer. So the testing, I was then testing an analyzer that was looking at an analyzer about an analyzer. It went down a rabbit hole quite deep. But yeah, MS Learn, Andrew Locke stuff, and then just a lot of playing around. Certainly Syntax Factory for source code generators, that was a lot of using that Roslyn quota Azure website. Literally just, I want that code. What do I not know? Because I can't make that code work. Oh, it's that thing. Okay, right. Let's see how that fits in. So yeah, there was a lot of using Roslyn quota and then going back into code and backwards and forwards. So, but once I'd got used to it, I found the learning curve wasn't as bad. But I had to spend a lot of time in it. If I did it a bit at a time, it just took a little bit longer. So yeah, source code generators was a whole other thing, but analyzers was just the MS Lens.
Great, thank you.
I'm going to keep you for your pizza for just 1 second. I'll draw prizes.
Shall I stop sharing now?
Okay, by all means. Yes.
Yes.
The folks that hello, you should all be able to hear me now, I guess, and also see the wheel. So this is for a JetBrains license. This is checked about 4 minutes ago, 5 minutes ago. So if you tweeted since then, probably sorry, you missed out. But and Andrew Douglas has won a JetBrains license. So congratulations to Andrew. And then live, I can go down here and remove Andrew. And then now this is a C#10 book of some sort, which I can't remember the name of. So, winner of the C#10 book. So JetBrains, obviously, JetBrains sponsorship. The C#10 book is Calix. So thank you very much. And Steve Collins, you have won the C#10 book.
Yes.
So congratulations. Yeah. So thanks once again to Steve Pears for his awesome talk on .NET and Roslyn. So round of applause for Steve.
Woo!
It's obviously to everybody that's come along in person and remote as well. So that's awesome. That obviously this wouldn't work without people watching. Thanks to our sponsors, BGSS, where you are, Calix for the book, JetBrains for the license, Cordius for what you will be eating shortly. Hopefully it's not too cold now. It's been there a while. Be all right. It's fine. And the drinks in the fridge. And yeah, thanks again. And we'll see you in the new year. There is no December because it's the last Monday of the December month. Would be a bad time to have a meeting or something like that. So sometime at the end of January, we'll see you back, hopefully here. Yeah, thank you again. Cheers. And see you later at, we're going to close the Zoom meeting now, everybody in remote. We'll be in touch on Twitter for the folks that won. So congratulations. And we'll see you later.
Cheers, MP.
Bye.
Thank you all.
Bye.
Thank you, those.
Thank you. Goodbye.
They're in the real world.
See you then.
See ya.